I'm Dr. Taylor Szyszka from the University of Sydney, and the title of my presentation is Building Offices for Proteins. Welcome to my home office, because like many of you, I've had to build one of these things this past year. But I actually found it to be a pretty useful exercise, because it forced me to think about what things I need in my immediate area to be most efficient. For me, this turned out to be a nice big work surface, comfy chair, well-stocked snack drawer, and of course, an office plant. I'm not quite sure what it is, but something about a bit of green in the workplace just does wonders for my efficiency. And plants actually serve as inspiration for my research, because I'm trying to build an office for a protein found in plants. See, plants get their energy from light and carbon dioxide through a process called photosynthesis. And one of the most important players in photosynthesis is a protein called rubisco, which is this amazing molecular machine that takes carbon dioxide and converts it into something that plants can use for fuel. This is called carbon fixation, and carbon fixation is super important. It's the way in which all of that atmospheric carbon dioxide gets taken out and turned into something that living things can actually use. Despite being so important, rubisco is actually pretty lousy at its job. It's super slow and super inefficient. And to compensate for this, plants need to use a ton of energy just to make enough of the stuff to get by. So my project is to build a sweet home office for rubisco. So by studying other organisms that do photosynthesis and brushing up on our plant research, we found that there are a few other molecules that kind of help rubisco along. Sort of like my snack drawer. So we want to take these helper molecules and put them in a sort of room with rubisco. Now, of course, we can't use a room like this one. So we're using a teeny tiny protein compartment, which is effectively a little hollow sphere made out of protein that we can actually engineer to house other molecules. So in this way, our compartment is like an office space, and inside we've got our helper molecules, making rubisco more efficient. Right now, these experiments are happening in test tubes, but we do eventually want to move them into plants. Because if we can improve the way that plant rubisco works, not only can we enhance a plant's ability to fix atmospheric carbon dioxide, but maybe they won't need to use so much energy just mass producing rubisco, and they can use this energy in other ways, which has implications for things like agriculture and food security. Now, these are really exciting and inspiring things to think about, so it's no wonder that my office plant makes me more efficient, because at the end of the day, I'm trying to make it a bit more efficient too. Thank you.